Setting up multiplayer can be confusing, especially with so many different approaches out there. A lot of tutorials either dive too deep into complex systems or rush through the basics without explaining the fundamentals. In this video, I'll walk you through a simple traditional UDP method for multiplayer networking. This approach has been used for years, and while it's not perfect, it's a great way to understand the core concepts of how multiplayer works. We'll set up a basic server, connect a Unity client, and host it on AWS so you can play online. By the end, you'll not only have a working multiplayer setup, but also a better understanding of why modern networking libraries have moved beyond this approach, and when it might still be useful. Let's get started. All right, let's set up our server. I'll start by creating a console application in C#. Inside this, I'll create a player class to manage player properties. By the way, all links and code snippets are in the description. Just copy and paste the player script. Then do the same for the server script. Copy the server code and paste it into program.cs. Once that's done, build the project. Our server is ready. Now let's move on to the client side. For the client, I'll create a Unity project. Inside it, I'll create a script called UDP Client. Open it and paste the client code. To visualize the setup better, I'll add a plane to the scene and apply a black material to make the players more visible. Next, I'll create an empty game object, name it Client, and attach the UDP Client script to it. Now, to represent the players, I'll create a cube, turn it into a prefab, delete it from the scene, and assign it to the player prefab field inside the UDP Client script. Before building, I need to adjust the sequence size so we can see other clients more clearly during testing. Alright, with the server and client set up, it's time to test. Going back to the console application, I'll start the server. Then I'll open the Unity build we created earlier. As you can see, everything works perfectly in a local environment. Now let's take it online using AWS so you can play with friends worldwide. I'll head to the AWS console and search for EC2. From there, I'll create a new instance, give it a name, and choose a Windows machine for this tutorial. We need a key pair to securely connect to our server, so I'll create one, name it, select Point PEM, and download it. Next, I'll allow HTTP traffic from anywhere by checking these two boxes, then launch the instance. This process takes about 5 to 10 minutes, so we'll wait. Once the instance is ready, I'll select it and click the Connect button. Under the RDP Client section, I'll open Remote Desktop Connection on my computer. Here, I need to specify which computer to connect to, so I'll copy the public DNS from AWS and paste it into the connection field. The username is provided in AWS. And now I need to upload the private key file we downloaded earlier to decrypt the password. After that, I can log into the server. Before running the game server, I need to install a required package. I'll go to the provided link, download the x64 version for Windows, and install it. This step is done directly on the AWS server, not the development machine. Now I need to upload our game server files to the AWS instance. I'll locate the console application folder on my local machine, then drag and drop it onto the AWS desktop. Before we can start the server, we need to allow traffic on port 7777 so players can connect. I'll open Windows PowerShell as an administrator and run the necessary command. Then, back in AWS, I'll navigate to the security settings, edit the inbound rules, Add a new rule for custom UDP, set the port to 7777 and allow access from any IP. After saving, I'll restart the AWS instance and wait a couple of minutes. Now I'll grab the public IP address of our instance from the AWS dashboard. Going back to Unity, I'll open the UDP client script and replace the local IP with this public IP. Then I'll rebuild the Unity client. Everything is set. First, I'll start the game server on AWS by running the server file as an administrator. Now moving back to our Unity build, I'll launch the client and connect to the server. As you can see, everything is working perfectly. Our multiplayer setup is now running over the internet using AWS.com. So now you've seen how the traditional UDP method works for multiplayer networking. This approach has been around for a long time, and while it gets the job done, it also has some limitations. First, UDP doesn't guarantee packet delivery, so you need to handle lost data manually. Second, scaling a server like this is difficult because there's no built-in matchmaking, relay servers, or cloud scaling. And third, managing security can be a challenge since you're directly exposing a UDP port to the internet. That's why modern multiplayer games use networking libraries like Mirror, Netcode for game objects, or Photon, which handle data reliability, scalability, and security for you. But even if you don't use this approach in a real game, understanding how it works is crucial, because this is the foundation of multiplayer networking. If you found this video helpful, hit the like button, subscribe, and turn on notifications so you don't miss future tutorials. Also, let me know in the comments if you want to see an alternative method using a modern networking library. Thanks for watching, and I'll see you in the next one.